what you're looking at isn't some alien world. This is here, on planet Earth. Extending beyond depths of 3,000 meters, the deep sea makes up half the ocean. Though it is a place we hardly know and almost never see, it is in fact the largest habitable space for life on Earth. And yet, with just over 20% of the seafloor mapped in any detail, only a tiny fraction of this incredible environment has been explored and studied. These animals and landscapes seem like the stuff of dreams. But in reality, these intricate and delicate systems play a vital role in sustaining life on Earth, and we are only just beginning to learn how vulnerable they are to climate change.
We humans have had an incredible impact on this space despite not being here, despite not doing a great job of exploring it.
The effects of a changing climate have already altered the deep sea and will continue to do so. Temperatures are estimated to rise by 1 degree Celsius in the deep ocean by 2100. It is almost certain to have harmful effects on organisms so finely tuned to survive in such environments. There are still countless undiscovered species dwelling in the abyss. Many of these organisms are so new to science that we are only just beginning to understand them, while others remain completely unknown.
Every time we go down into the deep ocean, we discover something new. There's something we haven't seen. There's a new species, a totally new type of habitat. There's nothing like that feeling and that excitement of looking at something that you know is new and trying to figure out how this new piece of our planet works.
Compared to conducting research on land, the challenges for exploring the deep sea are immense. Exploration of this world has only just begun, thanks to advancements in technology in recent decades.
Okay, here we go. Launching in 3, 2, 1. Launch now.
The single greatest impediment to studying the deep ocean is that it's not as transparent as air. I can look up with my own eyes and see the surface of the moon 250,000 miles away, but I can't even see half a mile into the ocean. That's why we have to develop technologies that can act as our eyes and ears.
Nice.
Ocean scientists are working with engineers and innovators to overcome the challenges of deep sea exploration and to prove that understanding this ecosystem is not only possible, but essential. We're developing exciting new technologies for oceanographic exploration, which feed us valuable information on the current state of our oceans.
I mean, it's been more than a decade of development to get these pieces of equipment to the point that they're at, where you can go out and do an experiment like this. And it's sort of long-term investment that I think is going to transform how we do ocean science.
One of the most fascinating aspects of oceanography for me is the discovery, when we are looking for something. And the question is always, how do we find it?
From remotely operated and autonomous technology to listening devices and imaging systems, a staggering array of innovative equipment is now at our disposal, shining a light into the deep for the first time. And the wondrous things we've illuminated have captured the world's attention.
Every single time an ROV dive takes place, we see something amazing. We see something we weren't expecting to see. We see life in environments where we don't expect to see life. The ocean is full of surprises, and our exploration is so in its infancy.
As these submerged visions appear, we realize that for every natural wonder on dry land, there's countless more underwater waiting to be discovered.
I always find it amazing to think that no human eyes have actually looked at this piece of seafloor before.
Most of us recognize the Amazon rainforest. Yet in the depths of our oceans stand ancient coral forests, teeming with life and far less explored.
Just like we all know, you cut down the rainforest, a lot of important functions are lost that those rainforests provide, including potentially new medicines. And so the same kind of concepts apply here to the bottom of the ocean.
I've said this a few times today, it's not every day you find a 500-metre tall reef in the Great Barrier Reef.
New coral reefs are still being discovered, thanks to the high-resolution maps we do have. But how many more are still hidden from us? Contrasting with these ancient coral ecosystems are bubbling superheated vent systems that support organisms right out of science fiction. Imagine a place so dark, toxic, and hot that the very idea of life proliferating there would seem absurd.
Crazy hydrothermal rock full of noxious chemicals, arsenic and selenium, and it's potentially radioactive, and yet it is teeming with life. And that's just astonishing to me. And you think about what you can learn from studying something like that. It's a tremendous opportunity.
From crushing pressures to pitch black darkness, from inhospitable cold to superheated systems, deep sea organisms are masterfully evolved to survive in places we originally thought life could not possibly exist.
There's all kinds of challenges living in an environment like this, yet life proliferates.
Until very recently, these alien worlds remained isolated from human impact. However, as we further our understanding of the deep, we are beginning to see just how vulnerable these environments are to the changes people are making to the planet.
It's devastating to see that impact on these ecosystems before we even fully understand them.
Everything on Earth is part of an interconnected system. Sea, air, land, and ice are linked by important life-sustaining processes.
Understanding what those processes are is incredibly important to how we understand how the climate of our planet works.
As we emit carbon dioxide into the atmosphere and our planet heats up, these processes shift and change. As the ocean warms, the conditions and patterns which sustain life are altered, and we may lose environments and species without knowing they ever existed.
We're the ones who are capable of having the greatest impact for good or for bad. You wouldn't go and build a house on land that you haven't surveyed, that you don't know what's under there. You wouldn't drink water that you haven't tested to see if it's clean or if it's poisonous. Studying the ocean in the way we're doing, and many others do, allows us to help us understand what our ocean is about, what it takes to keep it healthy, and how can we reap the greatest benefit from it through sustainable practices. How do we do the best job that we can of being the caretakers of our world?
From hydrothermal microbes used in the development of one of the first COVID drugs, to clinical trials using deep-sea compounds to treat lung cancer and Alzheimer's, there is an abundance of information in the ocean's depths that could be vital to our survival. And the deep may also hold solutions for mitigating the effects of climate change. The importance of understanding these environments is paramount.
By coming up with new ways to explore this largest inhabitable volume on our planet, we're essentially establishing a baseline, biologically speaking, of what's there, and then from there understand what changes we're making to it.
The future is hopeful, but there is still much more to discover, and so much that we still need to learn. Some deep-sea organisms are 4,000 years old, having started life when human beings were only just inventing how to write. Their environments have remained relatively stable for millennia. And now, we are accelerating change at an unprecedented rate. We must dive deep and look into these worlds beyond imagining to discover what is there, before they are lost forever. People from all around the world are working together to create the tools and methods to better uncover what lies hidden in these most inaccessible depths of the ocean.
We still have time to address this problem, to highlight and underscore ways to make things better, to change the way people think about things.
Through this vital work, we hope to unlock a profound understanding of our planet, our ecosystems, and ourselves. More than ever before, the deep sea needs us. And from the moment when life on Earth began, we need it too.